In today's video, I would like to introduce a very nice problem that was suggested by viewer. Indeed, it's a more challenged problem. It requires a lot of tricks, okay? But we are going step by step, showing all the details. Don't forget to support us by your subscribe and likes and comments. Now let's go ahead and get started. So first of all, before we proceed to the solution, I'm trying to find appropriate value of this one to make a nice factorization for this expression, okay? So I see 100, I can replace it with 1024 minus 924, okay? Because 1024 is the same as 4 to the 5th. So I will have the same power, 5th power. Then also 24 will be my multiple of 7. So it will be a nice factorization here, okay? Now let's do that. So get e to the 5th. 1024 is the same as 4 to the 5th, which equals 924, which equals 7 to the b, okay? Now let's go ahead, move over this term to the right and make it as a common factor with number 7. 7 to the b minus 1 plus 132. Because 7 is multiplied by 132 is giving us 924 after you moving over this term to the right. Then also keep in mind here, this 132 is the same as 2 square is multiplied by 3 is multiplied by 11. So which means it's going to be factorized on the factorization prime form. So now let's notice here we are going, let's factor out this one. So this one is the same as a plus number 4 factor e to the 4th is 8 to the 3 is multiplied by 4 plus e square is multiplied by 4 square minus a is multiplied by 4 to the 3 power plus the last term, which is 4 to the 4th, which equals to this one, 7 factor 7 to the b minus 1 plus 132. Okay, now here is the thing. Let's suppose b is superior to 2 because b equals 1, no solution. Why? Let's replace b with number 1 here. So you get 7 here. Moving over this 100 to the right, I get 7 minus 100, which is minus 93. Minus 93 is not going to be written on the form of the 5th power, which is impossible, which means we are going to keep b is superior to 2 as a natural number. Now if we have b superior to 2, this term is not going to be divisible by number 7, okay? Because this term is divisible by number 7 is okay, but this one is not be divisible number 7 because look at here, we have 2 square 3 11. We cannot divide this one by 7, which means GCD of these two terms equals 1. So this is very important. GCD of these two terms equals 1. What does this mean? Which means we are going to limit the number of choices. 7 can divide either this one or this one. Since we have GCD equals 1, 7 is going directly to this one or this one. Sometimes if you have shared divisor, common divisor I mean, 7 it can divide both. But since GCD equals 1, 7 is going directly to the one of these. But we don't know which one 7 is going to divisible by. Oh, absolutely, we are going by the way of contradiction to show that, okay? So if we think in this one will be the solution, we are going to prove the inverse one. We are going to go to the opposite way. Well, I'm going to assume 7 divides a plus number 4. We will find a contradiction, which means 7 must be divided this one. That's what we are going to do. So by the way of contradiction, suppose 7 not divides a plus number 4. We are going to ignore this one because this is enough to show this one, okay? So as we know, this one is verifying the Fermat. As you know, this one is satisfied the Fermat-Liouville theorem. So because 7 is a prime, not divised integer, which means we are allowed to apply the Fermat-Liouville theorem. So by the Fermat-Liouville theorem, we get e plus 4 all is raised to the number 6, because p minus 1 is a congruent to 1 mod 7. Okay, let's make some derivation here. I'm going to convert this number 4 to the minus 3. How come that? Because 4 equals 7 minus 3. Okay, so 7 will be 0, I will be left with minus 3. This one equivalent, a minus 3 to the 6 is a congruent to 1 mod 7. It's more clear, right? Now I'm going to take the square root on both sides. I will have two choices because I have even exponent, so which means one is, it will be positive, the other one is negative. So I will have the following. So this one, I will have a minus 3, all is raised to number 3, is a congruent to 1 mod 7, or a minus 3 to the 3 is a congruent to minus 1 mod 7. So we will have one of these is true, but we don't know which one is true, which one is not true. Okay, so I'm going to make some factorization as I did previously. I'm going to move over this number 1 to the left, then make the sum of two cubes and factor it out as I have previously. Okay, so by starting with the first one, we have to show this one first, then we move on to the second term. So absolutely this one will be followed similarly to the same argument, because you will have the same kind of things here. So now working on this one, I get a minus 3. Let's replace this one as like 1 cubed, because to make the difference of two cubes as I have here. Previously I have some, now I will make it as a minus sign between. Okay, so I get a minus 3 minus 1, which is a minus 4. Factor a minus 3, because we already have number 1 here, square, plus, because since I have minus sign between two cubes, which means I'm going to keep the plus sign all the way down. So I will have e minus 3 to the exponent 1 plus number 1, which means e minus 3 to the 0. This one is a congruent to 0 mod 7. Because I have moved over this number 1, I will be left with a 0 congruent to 0 mod 7. So I'm going to simplify this expression here. So this one equivalent, I get a minus 4. This one becomes a squared. So this one becomes minus 6a plus a, which is minus 5a. This one becomes 9, 3 squared 9. 9 plus number 1, 10. 10 minus 3, which is 7. Okay? Plus 7. Remember, we are reducing this one to mod 7. So I'm simply, this one will be 0. Then taking a out of these things here. Let's make this a like this. Then cancel this a like this. Because this one is 0. Which one is a congruent to 0 mod 7. Okay? We don't have equality because we have the congruent sign. So we are reducing, just reduce. So what does this mean? Which means 7 can divide a, or 7 divide this one, 7, or 7 divide this one, but we don't know which one 7 divides. So which means 7 divides a, or 7 divides a minus 4, or 7 divides a minus 5. It's more clear. Okay, so I'm going to go through each one. This one equivalent, a equals 7 is multiplied by k1 according to the Debye statement, which means a is a multiple of 7. Also this one is equivalent to a equals 7 is multiplied by k2 plus the remainder 4. How come this one? Because 7 divides a minus 4, which means a minus 4 equals k2 is multiplied by 7. By moving over this minus 4 to the other side, I will be left with this one. So also with the last one, I get a equals 7 k3 plus number 5. So I have these three things. We need to check them. Which one is right, which one is wrong. But but make sure we are going to find them all are wrong, because we are seeking for the contradiction. Okay, so what to do? I'm simply going to take each of these values and insert them into the original equation to see this equation satisfies these solutions or no. Okay, so taking this at the top here, I get e to the fifth. It will be replaced as a 7q1 all to the fifth. I'm working only with the first case, plus 100, which equals 7 to the b. This one is clearly a congruent to 0 mod 7. This one also I will have, 100. We know if you divide 100 by 7, you will have a remainder number 2 here. So I get this one, remainder 2. This one will be 0. So this one equivalent 2 is a congruent to 0 mod 7. It's impossible. It's a contradiction to have different remainders, which is impossible. Okay, so let's check the second one. So this one is verified, is a contradiction, doesn't work. The same, replacing those values which left into this one, you will find also the contradiction, reducing the things to the number to the mod 7, because since we are dealing with number 7 here, so this one will not work, this one will not work. Let's move on to the second case. Now we are going to work on this one. So I'm going to do the same thing. This minus 1 becomes minus 1 cubed. Moving over this one to the left as I did previously, I will have the sum of 2 cubes, so which means I get the first 8, a minus 3 plus number 1, because this minus 1 is going to move over to the right, become minus 3 plus number 1, which is a minus 2. Factor a minus 3 square, plus I have minus sign here, I get a minus 3 plus the last term, which is a congruent to 0 mod 7, because I have moved over these things to the left. I will be left with 0, congruent to 0, I will be left with 0 here. So what do we need to do now? Just simplifying this expression. I will have a minus 2 factor. This one will become, clearly you will have e square here, minus 6a minus this a, I will have minus 7a. This one is clearly a 9 plus 1, which is 10. 10 plus 3, which is 13, is a congruent to 0 mod 7. So this 7 will be 0. This 13 is a 14 minus 1. This one 0. I will be left with minus 1. So the reduced expression will be the following. Now I will have the same thing that I have previously here, k1 prime plus number 1, or a equals 7 k prime 3 plus number 2. Replacing these three values into your original equation and reducing the equation to mod 7, you will find a contradiction. None of those works. This one not working, which means both cases that I have mentioned before as a true assumption was wrong, which means 7 cannot divide a plus 4 was wrong, which means 7 divides a plus 4. Let's take this sign, replace it with this one. Now 7 divides a plus 4 by this proof that I have done here. Okay, so since we know 7 divides a plus 4, we are going to work on it. So which means equivalent is according to the divisibility statement, we get a plus 4 equals 7 is multiplied by k prime, for example. Okay, so let's reduce the equation to the mod 7, 0 mod 7. This one equivalent according to the divisibility statement. Again, I'm going to reduce this number 4. I'm going to put it on the form 7 minus 3. So this one will be 0. I will have a minus 3 is a congruent to 0 mod 7. Again, it's an equivalent. A equals 7 k plus number 3. So it's more clear don't mix this key prime with key, they are different, because we have dealing with a plus number 4. Now we are going to deal with e minus 3 here. So it's clearly here 7 divides this one, so which means 8 is a multiple, e is a multiple of 7, keeping remainder 3. Okay, this is true statement. Here is a challenged point for this problem. Here is a challenged thing for this problem. So we have proven one side. We have proven a equals 7k plus 3 as a true statement. Okay, we need to prove another thing, which is going to be like this, the same value of a, but you will have a different expression. Then we are going to make the comparison between two true statements. Then at the end we will find something very important. Okay, so the important thing that I'm going to show, we are going to show this k must be equal to 0. This is the problem, how to prove this one. Okay, so now we are going through something. Now we are going to take the advantage of the original equation by reducing this equation to the mod 4. Then we will see something very important. Then we move on ahead to the next step. Let's reduce the original equation to the mod 4. So if I'm going to do that, I will have e to the 5th. This is clearly is 0 because 100 is divided by 4 is given as 25. This one is a congruent to minus 1 to the b mod 4. Why that? Because we know 7 equals 8 minus 1. It will be 0 as you divide it. This one is going to give us two things. It's going to give us minus 1 mod 4 or 1 mod 4. Depends on the parity of b. If the p is even, it's going to give us this one. Okay, this one if b is even. This one if b is odd. If b is odd, I'm going to add number 4 here. I will have 3 or 3 because minus 1 is the same as 3 as you add in number 4 here. Okay, so we are going to show this one. We are going to show this one is a true statement. This one, as I said, is 3 mod 4 or minus 1 because you add in number 4 on it. Okay, so this is also we are going to show it. How are we going to show it? We are going to prove the parity of b first. Before we prove the parity of b, we are going to prove a is a prime. Okay, how we know this one is a prime? It looks like it's going to be a prime because we get number 1 here as a remainder, we get number 3 as a remainder. We know the prime, as you know, the prime number is always written on this form. P equals 4 something m plus 1 or p equals 4m plus 3 or p equals 4m plus 5, whatever. Okay, and so on and so forth. Like this is going to be right on these forms. Okay, it's going to take one of these forms. Okay, so now our example are going to prove p must be this one. Okay, now let's get rid of this one and move on to the proof. We are going to prove b must be odd. If b is odd, is going to be this one. Okay, so what to do? I'm going to go through the chart first to show where we have the possible values for this integer in order to show e is a prime. Okay, let's do it here. 3 to the 5th is the same as 3 square is multiplied by 3 square is multiplied by 3. 3 square is 9, remainder 1. This one is a remainder 1. This one is 3. You will have 3 as a remainder for the 4th. So the remainder 1, 7. I get 3 also here. So it seems e to the 5th belongs to this set 0, 1, and 3 only. Okay. So if you check carefully here, if you go back to the, if I'm going to check the parity of a, going back to the original equation, it's clearly a is odd because this one, because the right hand side of this equation is odd. This one is odd because you get 100 even, which means a is odd. If a is odd, which means it's going to tick either number 1 or 3. Okay, if it's going to tick number 1, which means B is an even, as we have here. If it's going to tick number 3, which means B is an odd. So we are going to show B is an odd. How are we going to show that? So from this chart, we know A is a prime. A also is a prime. Why is a prime? Because it's going to tick either form. It's going to tick 4k plus number 1 or 4k plus number 3, as we have discussed before. Okay, and also we know the possible reminders for this prime, specifically for a to the 5th, we get only these two things. So our prime is going to from this chart we have shown is going to tick only two possibilities, either one, this one or this one. So since we have shown everything, what's left from this chart? What's left now? We are going to show. We have a reminder 3 here. We are going to pick up the first one here. So after we show B is an odd. So by the way of contradiction, so suppose B is an even. So B is going to take this form 2m. Okay. So I will have the following. I will have e to the 5th, which equals 7 to the B is going to replace with this one. I will get 7 to the 2m. Let's move over this hanger to the right and put it on the first. And also I'm going to put it on this form, 10 square. So it's clearly giving us a difference of 2 squares, which you get 7 to the m minus 10 factor 7 to the m plus 10. So we have before we have shown is a prime. Have a factorization prime. Since this one is a prime, now we are allowed to transfer this one into the factorization prime, because this formula is valid for only if E is a prime. If it's not prime, if it's not a prime, we cannot do the following thing. The following thing is going to be written on this form. We get 7 to the m minus 10 equals to a to the I, and 7 to the m plus 10 equals e to the j, where is j is strictly superior than I. Okay, this is the formula I'm talking about. If a is not prime, we cannot do this one. Okay, so solving this equation, it's more simple. Making this equation minus this equation, I get a rate of 7m will be cancelled out. I will be left with 2 times 10. 20 is the same as 4 is multiplied by 5, which equals e to the j minus e to the I. Let's make e to the I as a common factor, since e to the I is smaller than e to the j. Get e to the I factor e to the j minus I minus number 1. It's more clear there. It's more clear here. This is even, because we already know e is a odd. This one is a odd. It simply is going to take this value 5. Without solving this equation, it's more simple. Now we find a equals 5 with I equals 1. It's more clear. Okay, insert back this value of a into the original equation to see what's the solution for this equation. 5 to the 5, because I'm replacing a with number 5, plus 100, which equals 7 to the b. This is clearly, if you are going to calculate this one, this is not power of 7. Okay, this is impossible. So which means we have contradiction here. What we have contradicted? We have contradicted this assumption. B cannot be even, which means B must be odd. Why? Because of this proof. We have proven that, we have shown the contradiction. Our assumption was wrong, which means B must be odd. If B is odd, this one will be a rod of this possibility. This is wrong. This is true. Okay, which means our prime A is going to write on this form 4 times, because it's a multiple 4 times k plus number 3, which is the first one. Okay, now we have shown a equals 4k plus number 3. So this one, it was statement number 1. This is one, statement number 2. If you take a look carefully at both statements were true. This one we have shown it before by previous proof. Then also this one we have shown it in different way. We found the same number, same integer, which is a equals 7, k plus number 3, and the other one a equals 4, k plus number 3. But the first one was a multiple of 7, keeping remainder 3, but the other one was a multiple of 4, keeping remainder 3. So at the end we have the same number as a remainder 3. But we have an error here. We cannot solve this equation. We cannot have two true statements written differently. In order to fix and maintain these two statements, we need to give k equals 0. Okay, k equals 0. If k equals 0, this one is driving us directly to say a equals 3, because replacing here. Because replacing k with 0, I will be left with number 3. Replacing k with 0, I will be left with number 3. So that means that's the right one. Okay. Now let's take this solution and insert it back into the original equation to find b. Okay. So equals 3. Replacing this one here, I get 3 to the 5th plus 100. 343 is the same as 7 cubed, which means we have a solution a equals 3. We have a solution equals 3 and b equals 3 also. Okay. So I have ended this problem. By the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you next video. Bye.